So in this video, I'll be solving this practice or mock AP Pre-Calculus free response question. No calculator is allowed on this one. And I found this problem on the website crackap.com. So let's try this problem out. So the function f is given by this guy, this rational function, where, what exactly is this notation though? Let me go back to the website to check real quick. I think that's x cannot equal to 2. That's a weird notation. Okay, where x, so let me write it in, cannot equal to 2. I believe that's what it's trying to say. So part A says, find the equation of the vertical asymptote of the graph of f. By the way, the website does have a worked out solution, so I'm just going to still do it. I might do it a little differently than how they do it. It just depends on the problem. Like in a previous video where it was like solving logarithmic equations or simplifying them, I solved it in a completely different way than they did. And we'll see if I approach it differently in this video. Okay, so to find the vertical asymptote for a rational function, that's when the denominator is equal to 0. Because when we divide by 0, that would not work, that's undefined. In the case of a rational function, that there usually is a vertical asymptote. Sometimes there could be a hole there if things cancel in the numerator and denominator, but in this problem, that's not the case here. So the vertical asymptote here, well, when are we dividing by 0? That's when x is equal to 2. They even told us that x cannot equal to 2. So there is a vertical asymptote at x is equal to 2. So the equation is also x is equal to 2. So you have to write it as the equation. This would be the equation. X equals 2. X equals 2 is a vertical line. Find the equation of the horizontal asymptote of the graph of f. So to find horizontal asymptote, do you remember how to do that? We do the degree test. This works for rational function. So the degree at the top, meaning the biggest power of x, is x to the first power. The biggest degree on the bottom is also 1 because it's x. Okay? So since they're the same degree, remember there's 3 cases. If the degree at the top is bigger than the degree of the bottom, that's no vertical asymptote, there's a slight asymptote. When the degree at the bottom is bigger than the top, there's a vertical asymptote at y is equal to 0. When the degrees are the same, we take the ratio of the leading coefficients. So it'll be y is equal to, the ratio is you divide 2 things. So it'll be 3 over -1. The leading coefficient is 3 on top, that's in front of the x. For the bottom, -1 is in front of x. So the equation is y is -3. That is the horizontal asymptote here. Okay. Next, find the coordinates where the graph of f crosses the x-axis. Where it crosses the x-axis, so let me show here, that's when y is 0, or we're finding the zeros of the function. Okay, so let me do that. Let me do it on the side over here then. So part C, we want to set f equal to 0, because f of x is our y. So 0 is equal to 3x plus 6 over 2 minus x, and we solve for x. We multiply by 2 minus x on each side, we get 0 is equal to 3x plus 6, so x would be -2. That would be the x coordinate. Okay, so the coordinate should be -2, 0. Okay, so this would be the answer for part C. You had to write it as a coordinate because they asked for the coordinates. Part D, find the coordinates where the graph of f crosses the y-axis, so we're asked for the y-intercept. When it's on the y-axis, the x value is 0, so we set x is equal to 0. So f of 0 is what we're finding, is equal to 3 times 0 plus 6, so I'm plugging in x as 0 into here, over 2 minus 0. So that's equal to 6 over 2, which is 3. So our y-intercept would be 0, 3. Okay? Part E, sketch the graph of f on the axes below. So we're going to use our answers from part A to D to help us out here. There's a y-intercept at 0, 3, something like that right there. Mark that point. There's the x-intercept at -2, 0. will be something like that. We know there's a vertical asymptote at x is equal to 2, so something like this. So usually for asymptote, I draw a dotted line. There's a horizontal asymptote at y is -3, so something like this. Okay? And we already have an idea of how it should look. Of course, we could always just plug in other values of x to get a shape. Okay? And we could also find the end behavior, or the limit, as x approaches -infinity and +infinity. But actually, we know the end behavior because that is the horizontal asymptote. Okay? So we know that since there's an asymptote at y is -3, so as x goes to -infinity, it should go something like that. Okay? And then it needs to go through this point, and then we know there's a vertical asymptote at x is equal to 2. So it should go something like this. Right there. And then we know that it should have something over here also, because we can plug in, like, for example, x is 10, we would get 30 plus 6 over -8. So that's some negative value here. So it should look like this. We know there's a vertical asymptote at x is equal to 2 again. So as x approaches 2 from the right, it should approach the asymptote. And then as x approaches infinity, we know there's a horizontal asymptote, so it should approach that value of, what was it again? -3. So this is just a rough sketch of how it should look. Okay? Even the website says, use everything we found from parts A through D, and just plug in some additional points to get your curve. So over here, you probably need to plug in some additional points to help find out that it looks something like that. Okay, next, function g is defined by g of x is this guy, where x, I believe this is x is not equal to 2. Okay, given that g of x is g inverse of x, find the value of a. Okay, so g of x is equal to g inverse of x. So let's try to find a general form for g inverse. So how do we find the inverse? We switch to y and the x. So x is equal to ay plus 6 over 2 minus y. And then we solve for y to get y equals something. So it'll be x times 2 minus y is equal to ay plus 6. Okay, so then let's distribute this x. 2x minus xy is equal to ay plus 6. Move all the terms with y on one side and all the terms without y on the other side. So we get minus ay minus xy is equal to 6 minus 2x. Factor out a y here. So it would be minus a minus x. Okay, and then we solve for y. So then y is equal to 6 minus 2x over minus a minus x. Okay, so we want to set this is g inverse. Okay, they tell us that g inverse is equal to g of x. So let's set these two equal to each other. So it'll be ax plus 6 over 2 minus x. That's our g of x that they give us. And our g inverse we found was 6 minus 2x over minus a minus x. Okay? So now what do we do? They look quite close actually. So let me let me rewrite this side to match more this side a little bit. So it'll be, and then I can actually rewrite back up. Let's rewrite this side a little bit first. So let's get it to, actually we don't need to rewrite anything. We can see that a is -2, if you're able to see it. Because minus x is here and here. We have minus a should be equal to 2. So a is -2. Up here, we have 6 and 6. So then ax should be the same as -2x. So a is -2. And that's the answer. Okay, so this was my first time doing this. So you can see how I thought through the problems. Okay, so that's it. This was quite quick, actually. It took me less than 10 minutes. And how much time do they expect for this one? 15 minutes. So you can clearly see that if you understand the concepts of like asymptotes, intercepts, and inverse, you can you should be able to do this quite quickly. Okay? Please like and subscribe if this video has helped you as always. And please look out for the next video where I'll solve another one of the problems on this website.